floor is yours.
Thank you. Okay. So the work I'm going to present has been developed in the frame of the Paris Reinforced project, that is Horizon 2020 project, and the work that I have developed together with my colleagues started from the idea of analyzing the long-term impact of COVID-19 pandemic, focusing specifically on the EU energy dimension. I have structured the presentation as follows. Okay, I will briefly introduce the scope and the motivation of our study, and then I will say a few words about the Paris Reinforced project. Then I will briefly explain the methodology that we have followed in this modeling exercise, putting particular attention on the interpretation of behavioral changes. That was one of the key points of our study. And finally, I will give an overview of some results and insights that we have obtained, mainly on CO2 emissions, on final energy consumptions, and investments. So the idea of this study came from the consideration that the events of the 2020 and current events still led to rapid mutation of the demand of services, and this led to impacts on the energy dimension. So we saw a general reduction of energy services demand, but with different responses within and across sectors. As probably you already know, the response of the European Commission was represented by the 2020 Next Generation EU package, that is a stimulus package aiming to support the economic recovery of the European countries. But in order not to stay on the pathway of decarbonization that is foreseen by the European Green Deal, the measures included in the Next Generation EU package are supposed to boost somehow the climate action of the European Green Deal. So we realized that all these transformations and the answers of the European Commission could lead to a potential to potentially modify the economic structure of the EU, and probably also reinforce transformation that are already in place. So we wondered if possible deviation on future energy consumption could be realistic from the pre-COVID scenarios. So with this work, we want basically to answer to three questions. How could European energy system respond to the COVID-19 economic impact, and how can it develop to 2030? What is the impulse that this transformation led on the citizen behavior changes in the frame also of the 2050 EU net zero target? And finally, what contribution could give in the energy transformation the stimulus package, the Next Generation EU package? A few words on the Paris Reinforced project. That is the frame of our work. It involves 13 European partners. The consortium involves 13 European partners and 5 international partners, and it gathers a number of modeling tools. And the objective is to design a common scenario protocol by wisely interlinking all the possibly the models in the consortium, with the proposal of creating two sets of scenarios, basically one on the current policy set called Where Are We Heading scenarios, and the second set called Paris Reinforced, aiming to propose policy scenarios, including the main EU challenges. So assessment of COVID-19 impact and increasing ambitions of the Green New Deal, and reinforcing the Paris Agreement measures. From here, it comes the name of the project. And a particular important point of the project is represented by the co-design process of the scenarios with stakeholder and the stakeholder engagement. This modeling exercise that I'm presenting is based on a soft link of two different modeling tools for the European Union, part of the consortium of the project. One is a macroeconomic model, Nemesis, and the other one is an energy system model for European Union, that is the E4SMA version of the U times. Basically, the soft link is represented, works as the Nemesis elaborates and produces economic outputs, and U times receives economic outputs from Nemesis and produces energy outputs. In this analysis, we have concentrated on three main layers or dimensions, if you prefer, that somehow integrates and overlap. First of all, the economic situation in European Union before and after the COVID-19 pandemic. The second layer or dimension is the intensity of the EU climate action. And the third dimension is represented by the behavioral changes that I was mentioning, and the role that they can have, that behavioral changes could have in the scenarios. So for the first dimension, so to assess the economic impact of COVID-19 pandemic, we have developed three storylines. The first one is the pre-COVID case called Where Are We Heading? And it substantially considers an economic growth of GDP projection of more or less 1.2% in 2030 compared to 2020, and two post-COVID case, one considering a full economic recovery, and a second one considering a limited economic recovery. Here in this image, you can see the trajectory of the pre-COVID case, the black one. The blue one is the full recovery case that considers a sort of alignment with the preconditions of COVID in 2025, while the yellow line is the post-COVID case with limited economic recovery that still in 2030 remains lower than the pre-COVID trajectory. To assess the second dimension, so the EU climate action, we developed two main storylines: a current policy case that includes the measures and policies included in the EU 2030 climate and energy framework to date. And in this table here, you see an overall overview of the measures that are included in the storyline, and a more ambitious storyline that includes the 2030 climate target plan, considering a minus 55% reduction in greenhouse gas emissions in 2030 in comparison to 1990. These to achieve the net zero target in 2050. We have analyzed, the third dimension that we have analyzed, as I was mentioning, is the citizen behavior change and the role that the behavior change can have in the scenario. First, we have to distinguish two main drivers that characterize the behavior changes. The first one is the fact that behavior changes analyzed can be due to environmental concerns, and the second one, the fact that further behavior changes were related to COVID. So we had to distinguish these two factors. We focused on two sectors in particular because the literature on that were available gave more quantitative information on these two sectors that are namely transportation sector and residential sectors. And we consider the impact of remote working and impact on aviation sector. So for the behavior changes due to environmental concerns, we have considered 6% less private car commutes in the transportation sector, and balanced by a 2% higher energy demand in the residential sector. This value has referred to the World Energy Outlook from the International Energy Agency 2020, and consider a workforce from home of the 25%. The share of commutes to work is 40% of total passenger journeys, and considering 3 days per week. In the aviation sector, we included a 34% lower demand in the aviation sector. I didn't mention before, but with environmental concern, we mean the behavior changes that are already, let's say, required or foreseen in order to achieve the environmental target of the European Union. So they are somehow not related to the impact of COVID. While the behavior changes that reflect somehow the impact of COVID-19 pandemic consider a 10% less private car commutes in the transportation sector, balanced by a 3.3 higher energy demand in the residential sector. This because we considered workforce from home increase to 40%. In addition, we have considered the impact of teleconferences, and we added a further reduction of 10% in lower energy demand in the aviation sector in 2030, compared to the reduction assumed for the behavior changes due to environmental concerns. Here I show you some of the results, and here you see the trajectory of total CO2 emissions. In the black line, you see the where are we adding trajectory, and in the red line, you see the trajectory that includes the minus 55% reduction. And you see also, you recognize also the contribution of the different sectors. Here, you don't see the impact of the COVID-19 pandemic because the, let's say, the boundary of the CO2 emission trajectory to achieve the environmental target is active also in the scenarios including the COVID-19 pandemic. But the impact of COVID is visible on sectoral CO2 emissions. And here you see the two COVID scenarios assumed, the full recovery scenario and the low recovery, limited recovery scenarios. And here you see a difference in the transportation sector emissions, where in the short term, the limited economic recovery presents higher reduction compared to full recovery, and higher emissions in the power generations. This because the overall the energy systems in the case of the limited economic recovery presents a lower push to decarbonization, since we see also a reduction in the final energy consumption. Here you see two final energy consumption in the two cases, full recovery here this time on the left, and the limited economic recovery on the right. And you see that, of course, the major impact is in the short term, but in the limited case, the limited economic recovery case, it remains until 2030, while in the full recovery case, it aligns to pre-COVID case quite soon. So in 2027, the impact is very limited. Okay. Here you see in cascade the role of the behavioral changes. We have applied the behavioral change in cascade to the previous scenario, in particular on the full recovery case. And the interesting output here is that the amount, the contribution of the behavioral changes is, in the short term, is comparable to the, let's say, the impact of the contribution in the reduction of final energy consumption due to the economic impact.
About 1 minute left.
Okay. Finally, I'm showing you the results in terms of power generation investment cost from 2019 to 2030 obtained in the full set of scenarios that we have run. And the range obtained is from 560 billions to 740 billions. It is interesting to notice that in both cases where in those cases where the behavioral changes are included, so both in the pre-COVID and the post-COVID scenarios, the cost reduces quite a lot. And here you see the range of percentage of investments allocated to renewables, and it is from 55 to 72%. We made finally a comparison with the amounts of the economic package from the Next Generation EU. Probably most of the participants already know some details of it. It amounts to 750 billions and foresees at least 37% of addressed to climate action. This, of course, climate action does not mean necessarily all energy transformation. But if you want to make a rough comparison, the 37% corresponds to 277 billion euros, including grants and loans. And this, compared to our results, in case of full recovery, represents the 48% of the investments. In reality, we have made, and I'm going to conclude, a more detailed analysis of the destination of the funds. And we have considered only the grants coming from the European Commission. So among the different financing mechanisms in which the Next Generation EU actually is framed, we have analyzed that only 2 of them are applicable, let's say, for giving grants to energy transformation. And they are, in particular, the Just Transition Fund and Recovery and Resiliency Facility mechanism. And the range coming from this more detailed analysis goes from 10 billion euros to 322 billion euros. And again, if you want to make a rough comparison, this is in line, is comparable with the amount of renewable investments obtained in the post-COVID case, considering a full recovery, economic recovery, and the behavioral change. With this, I have concluded. I want to thank my colleague, and I want to say also that this work has been developed in collaboration with Soreco, so Mr. Boitier, Lemoine, and Paul Zagamet. Thank you.
Thank you very much, Gabriele. There is already a question for you in the in the question and answer section.
What is the criteria for repeating the iteration process in your modeling approach? So if I think you referred to this slide, actually, I could not explain in detail how the soft link works, but since also Nemesis is able to provide some energy outputs, in case the energy outputs and from Nemesis and from EU times are not aligned, we repeat the iteration, modifying let's say the parameters in the Nemesis model, until both models provide the aligned energy outputs. This is because we have considered that the energy system model is more reliable in terms of energy outputs compared to the macroeconomic model.
Thank you, Gabriele. Maybe just one more question. Was wondering whether, with respect to behavior change, whether you've considered that due to the possibility to work remotely, some people may choose to live further away from work, and it could potentially increase the commute time for them for whenever they work from office.
Yes. We have considered this, and referring to the World Energy Outlook, these assumptions basically come from there with some modifications on the European context, but these numbers actually evaluate also this counter effect, even though this counter effect is not really, the literature on this is quite few, so there are no real, let's say, quantitative assumption on this counterbalance effect. But it's clear that it might be to include if literature actually, if assumptions are available.
Thanks. So we don't have time for any further questions. From my side, I would like to thank all the panelists for very interesting presentations.